National Electrical Code Article 725 addresses the requirements for electrical control circuits and signaling circuits. It stipulates that these circuits cannot be installed in the same raceway, cable, or enclosure as conductors of electric light, power, Class 1, or non-power limited fire alarm circuits, unless specifically permitted elsewhere in Articles 725 through 840. There are exceptions to this rule. Firstly, when the conductors are separated by a barrier, such as a metal divider or a non-conductive barrier, commingling the two distinct types of conductors are permitted. Secondly, when the control circuits are rated for the same voltage as the power conductors, it is permitted. In the scenario presented, running control wires in the same manhole as 480 volts feeders without a barrier is not compliant with National Electrical Code Article 725.17d. To adhere to the National Electrical Code, specific requirements must be met. Firstly, the control wires must be physically separated from the 480 volts feeders by a tangible barrier. Secondly, the control wires must be rated for at least 480 volts. It is recommended to firstly install a separate conduit or raceway exclusively for the control wires. Secondly, use a barrier within the manhole to positively separate the two distinct types of conductors. Thirdly, ensure that the control wires are rated for a voltage equal to or greater than the voltage of the feeders. Failing to comply with the National Electrical Code requirements for separating control wires and power conductors can lead to several negative outcomes. Firstly, safety hazards such as electrical shock or fire are increased. Secondly, equipment damage is a possibility. Thirdly, code violations will be issued. To further clarify Article 725, it is essential to understand the definitions and scope it encompasses. Control circuits, as defined by the National Electrical Code, are circuits that control other circuits through devices like relays, switches, and conductors. Signaling circuits are used for communication purposes, such as fire alarms, security systems, and data transmission. The concern addressed by Article 725 is the potential for dangerous interaction between power and control or signaling circuits. High-voltage power conductors can induce current in nearby low-voltage control or signaling conductors, causing malfunction, damage, or even fire. The code prioritizes safety by requiring physical separation or voltage rating equivalence. Article 725 covers various types of control and signaling circuits, including Class 1, Class 2, and Class 3 circuits. Class 1 circuits are power limited and have specific voltage and current limitations. Class 2 and Class 3 circuits are further restricted in terms of power output and are considered safer due to their lower energy levels. However, even with Class 2 and Class 3 circuits, separation from power conductors is generally required unless the exceptions mentioned earlier apply. The use of barriers is a common method for achieving separation. Barriers can be made of metal or non-conductive materials and must be securely installed to provide a physical division between the power and control or signaling conductors. The barrier must be sufficient to prevent accidental contact or arcing between the conductors. Another approach is to use separate raceways or conduits for the different types of circuits. This provides a complete physical separation and eliminates the risk of interaction. When using separate raceways, it is important to maintain proper spacing between them to prevent inductive coupling, especially with high current power conductors. The voltage rating of the control wires is also a critical factor. If the control wires are rated for the same voltage as the power conductors, the risk of insulation breakdown and arcing is reduced. However, it is still recommended to provide physical separation whenever possible. In the context of a manhole, where space is often limited, careful planning and execution are necessary to ensure compliance with Article 725. The use of cable trays or ladder racks can help to organize and separate the different types of conductors. Barriers can be installed within the cable trays to provide additional separation. When installing conductors in a manhole, it is important to follow all applicable National Electrical Code requirements for conductor sizing, insulation, and support. The conductors must be properly secured and protected from physical damage. The manhole itself must be adequately ventilated and maintained to prevent the buildup of moisture or hazardous gases. In summary, National Electrical Code Article 725 mandates the separation of electrical control circuits and signaling circuits from power conductors to ensure safety and prevent equipment damage. Exceptions to this rule exist when conductors are separated by a barrier or when control circuits are rated for the same voltage as the power conductors. Compliance with Article 725 requires careful planning, proper installation techniques, and adherence to all applicable National Electrical Code requirements. Failing to comply with these requirements can result in serious safety hazards, equipment damage, and code violations. Consider a scenario where 480 volts power feeders and low voltage control wires for sensors are run in the same manhole without any separation. If the insulation on the power feeders were to become damaged, the high voltage could come into contact with the low voltage control wires. This could result in a dangerous electrical shock hazard for anyone who comes into contact with the control wires or the equipment they are connected to. Additionally, the high voltage could damage the sensitive electronic components in the sensors and control circuits, causing them to malfunction or fail completely. Furthermore, the presence of high voltage in the control circuits could create a fire hazard, especially if flammable materials are present in the manhole. By properly separating the power and control circuits, these risks can be significantly reduced. The barrier provides a physical barrier that prevents accidental contact between the conductors. The use of separate raceways ensures that the conductors are completely isolated from each other. The voltage rating of the control wires ensures that they can withstand the voltage of the power conductors in the event of an insulation failure. In addition to the requirements of Article 725, it is also important to consider other applicable National Electrical Code requirements. For example, Article 300 covers general wiring methods and materials. Article 310 covers conductors for general wiring. Article 314 covers outlet boxes, device boxes, and pull boxes. Article 392 covers cable trays. By following all applicable National Electrical Code requirements, electrical installations can be made safe and reliable. It is also important to consult with a qualified electrical engineer or contractor to ensure that the installation complies with all applicable codes and standards. These professionals have the knowledge and experience necessary to design and install electrical systems that are safe, reliable, and efficient. They can also help to identify and address any potential hazards or code violations. In conclusion, National Electrical Code Article 725 is an important safety standard that must be followed when installing electrical control circuits and signaling circuits. By properly separating these circuits from power conductors, the risk of electrical shock, equipment damage, and fire can be significantly reduced. Compliance with Article 725 requires careful planning, proper installation techniques, and adherence to all applicable National Electrical Code requirements. Always consult with a qualified electrical engineer or contractor to ensure that the installation complies with all applicable codes and standards. Let's delve deeper into the specifics of conductor voltage ratings and how they relate to National Electrical Code Article 725. When selecting control wires for use in proximity to power conductors, it's crucial to choose wires with an appropriate voltage rating. The voltage rating indicates the maximum voltage that the wire's insulation can safely withstand. As previously mentioned, National Electrical Code Article 725 permits the mixing of control and power conductors if the control wires are rated for the same voltage as the power conductors. However, it's generally best practice to exceed the minimum voltage rating requirement for added safety and reliability. For instance, in a 480 volt system, using control wires rated for 600 volts would provide an extra margin of safety. This higher rating helps to account for potential voltage spikes or surges that may occur in the system. Furthermore, the type of insulation used on the control wires is also important. Common insulation types include polyvinyl chloride, cross-linked polyethylene, and rubber. Each insulation type has different properties in terms of temperature resistance, moisture resistance, and chemical resistance. The selection of the appropriate insulation type depends on the specific application and the environmental conditions in which the wires will be installed. In a manhole environment where moisture and chemical exposure may be present, it's important to choose an insulation type that is resistant to these conditions. Another important consideration is the ampacity of the conductors. Ampacity refers to the maximum amount of current that a conductor can safely carry without overheating. The ampacity of a conductor is determined by its size, insulation type, and the ambient temperature in which it is installed. National Electrical Code Table 310.15b16 provides ampacity ratings for various types of conductors under different conditions. It's important to select conductors with an ampacity that is sufficient to carry the expected load current. Overloading conductors can cause them to overheat, which can lead to insulation damage, fire, or equipment failure. When installing conductors in a manhole, it's also important to consider the effects of dirting. Dirting is the reduction of a conductor's ampacity due to factors such as ambient temperature, conduit fill, and the presence of other conductors in the same raceway. National Electrical Code Article 310.15 provides dirting factors for various conditions. It's important to apply these dirting factors to ensure that the conductors are not overloaded. In addition to conductor voltage ratings and ampacity, it's also important to consider the grounding and bonding requirements of the National Electrical Code. Grounding is the connection of electrical equipment and circuits to the earth, which provides a path for fault current to flow back to the source. Bonding is the connection of metal parts of an electrical system to create a continuous electrical path. Grounding and bonding are essential for safety, as they help to prevent electrical shock hazards and equipment damage. National Electrical Code Article 250 provides detailed requirements for grounding and bonding. It's important to follow these requirements carefully to ensure that the electrical system is properly grounded and bonded. In the context of a manhole, it's important to ensure that all metal parts of the manhole, such as the cover and any cable trays or ladder racks, are properly bonded together and connected to the grounding system. This helps to prevent the buildup of static electricity and provides a path for fault current to flow back to the source in the event of an electrical fault. Furthermore, it's important to ensure that all electrical equipment installed in the manhole is properly grounded. This includes transformers, switchgear, and any other electrical devices. Proper grounding helps to prevent electrical shock hazards and equipment damage. Let's consider the practical application of these principles in a real-world scenario. Imagine a new commercial building is being constructed and requires a 480 volts power distribution system. The system includes several 480 volts feeders that run from the main switchboard to various pieces of equipment throughout the building. In addition, there are numerous low-voltage control circuits that are used to control lighting, HVAC systems, and other building automation functions. The engineer has designed the system such that some of the 480 volts feeders and low-voltage control circuits will run through the same underground manholes. To comply with National Electrical Code Article 725, the engineer must ensure that the control circuits are properly separated from the power conductors. One option is to install a physical barrier between the power and control circuits within the manholes. This could be accomplished by using a metal divider or non-conductive barrier to separate the conductors. Another option is to use separate raceways for the power and control circuits. This would provide a complete physical separation and eliminate the risk of interaction. In addition to the separation requirements, the engineer must also ensure that the control wires are rated for at least 480 volts. This will help to prevent insulation breakdown and arcing in the event of a fault. The engineer must also consider the ampacity of the conductors and apply any necessary dirting factors. This will ensure that the conductors are not overloaded and that they can safely carry the expected load current. Finally, the engineer must ensure that the entire electrical system is properly grounded and bonded in accordance with National Electrical Code Article 250. This will help to prevent electrical shock hazards and equipment damage. By carefully considering these factors and following all applicable National Electrical Code requirements, the engineer can design a safe and reliable electrical system for the new commercial building. It's important to remember that electrical safety is paramount and that compliance with the National Electrical Code is essential for protecting people and property from electrical hazards. Moreover, consider the implications of using fiber optic cables for control and signaling purposes. Fiber optic cables are immune to electrical interference and do not conduct electricity, making them an inherently safer option for use in proximity to power conductors. However, even when using fiber optic cables, it's important to follow proper installation practices and to ensure that the cables are adequately protected from physical damage. National Electrical Code Article 770 covers the installation of optical fiber cables and raceways. It's important to follow these requirements carefully to ensure that the fiber optic cables are installed safely and correctly. In addition to fiber optic cables, wireless communication technologies are also becoming increasingly popular for control and signaling applications. Wireless systems offer several advantages, including reduced wiring costs and increased flexibility. However, wireless systems are also susceptible to interference and security vulnerabilities. It's important to carefully consider these factors when designing and implementing a wireless control system. National Electrical Code Article 725 does not specifically address wireless control systems. However, it's important to ensure that wireless systems comply with all applicable National Electrical Code requirements for safety and performance. This includes requirements for grounding, bonding, and overcurrent protection. Furthermore, it's important to follow industry best practices for wireless security to protect the system from unauthorized access and control. Let's further explore some advanced techniques for separating power and control circuits. One technique is to use shielded cables for the control circuits. Shielded cables have a metallic layer that surrounds the conductors and provides protection from electromagnetic interference. The shield is typically grounded, which helps to divert any induced current away from the conductors. Shielded cables are particularly useful in environments with high levels of electromagnetic noise. Another technique is to use surge protection devices. Surge protection devices protect electrical equipment from voltage spikes and surges. These devices are typically installed at the point of entry of the power or control circuits and help to divert any excess voltage to ground. Surge protection devices can help to prevent damage to sensitive electronic equipment. A third technique is to use isolation transformers. Isolation transformers provide electrical isolation between the power and control circuits. This helps to prevent ground loops and reduces the risk of electrical shock. Isolation transformers are typically used in applications where safety is a primary concern. When implementing these advanced techniques, it's important to consult with a qualified electrical engineer or contractor to ensure that the installation complies with all applicable National Electrical Code requirements and industry best practices. These professionals have the knowledge and experience necessary to design and install electrical systems that are safe, reliable, and efficient. Remember, electrical safety is not just a matter of following the National Electrical Code. It's also a matter of using good judgment and common sense. Always take the time to plan your electrical installations carefully and to ensure that they are performed by qualified personnel. By following these guidelines, you can help to protect yourself, your family, and your property from electrical hazards.